Hello everyone and welcome to this video on Introduction to NumPy for Beginners. NumPy is an extremely powerful and extensively used Python library when it comes to the field of data science and machine learning. It stands for numerical Python, NumPy for short, and when we talk about NumPy, we're basically talking about dealing with matrices, 1D vectors, 2D matrices, arrays for short. So in this video and in the up and coming series videos, I will be going over the commands of NumPy. I will be going over some exercises which can help you guys get comfortable with NumPy, and I will be going over a problem in which I used NumPy alone and not any sort of Python library to implement a machine learning algorithm. Obviously that is for another video, but in these videos let's just get started with the basics of NumPy. So the first thing I want you guys to do is to check whether you have NumPy installed or not. If you have a conda or in a conda environment, you can say you can do conda install NumPy, but pip install NumPy will work just as fine. So I want you guys to execute this command, pip install NumPy. Cell is being executed. In my case, the requirement is already satisfied. NumPy is installed. If just in case you guys don't have it, Python will install it for you. And once you have NumPy installed, the next thing I want you guys to do is type in import NumPy as np. So if these two command lines work fine for you, if you guys are not getting any errors, that's good. Feel free to watch the next feel free to watch the rest of the video. But just in case if you guys are getting any sort of problems with installation of NumPy, or if you can't import NumPy, please let me know in the comments and I can help you. I can help you guys out personally. So okay, let's just assume you guys have NumPy installed, you have imported NumPy. Let's say I have a list 1 2 3 4. It has 4 elements, 1 2 3 4, and I want to represent it as a 1D vector or as an array. So I can do is I can pass in the command np.array, and I can cast it with the list that I have, my underscore list. I cast it with the list I defined earlier, and now I get an array with 4 elements. I get a 1D vector. So yeah, that's pretty much it. I took my list and I'm now able to represent it as a 1D vector. So this is what the np.array command does for us. But this is a 1D array. What if I want a 2D matrix? What I can do is, let's say I define another list by the name of underscore list 1. It takes in 3 elements, but these 3 elements are lists themselves. So what I mean by that is 1, 2, 3. Obviously, if you guys watched my Introduction to Python for Beginners crash course, I went over nested lists in quite some detail. So this will not be something that is completely alien to you guys. So let's say I define a list by the name of my list 1, 3 elements inside of it, and each of these elements is a list themselves. So basically I have a nested list. If I want to represent this nested list in the form of a 2D matrix, what I can do is I can call my np.array command, and I can pass in my list 1 variable, and now I have my list as a 3 cross 3 matrix, 1 2 3 3 4 5 6 7 8. So yeah, this is how we can convert any sort of list into a 1D vector or a 2D matrix using the array command. The next command that I would like to go over is the arrange command, the np.arrange command. So we already went over the range function in quite some detail in the beginner crash course, beginners, the Introduction to Python course for beginners. So what the range function does is that it returns all numbers starting from the first number all the way but not including the last number. And if I were to wrap this inside of a list, I would get a list back. So the range, or you can say np.arrange function, it does something very similar. If I were to pass in 2 arguments, the first argument is the starting number and the second argument is the ending number but not including the ending number itself, I will get an array with with all of the numbers that come between these two numbers, 0 to 10. So this is what the arrange function does for us. There is a third argument I can pass in over here. The third argument is basically the step size or the interval difference. So let's say I pass in a step size of 2. Now I get all the numbers between 0 to 10 but with an increment of 2. So 0, 2, 4, 6, 8. If I were to say 3, I will get all the numbers between 0 to 3, but with an increment of 3. 0, 3, 6, 9. Let's say 4. I get 3 numbers, 0, 4, 8. So yeah, this is what the arrange function does for us. It takes a starting number, it takes an ending number, it returns all numbers, all numbers starting from that number up to but not including the ending number, and with a step size or an increment size that we pass into it. It can be 2, it can be 1, it can be any number of your choice. So this is what the arrange function does for us. It returns a 1D vector, taking in 3 arguments, it returns a 1D vector. So moving forward, the other command that I would like to go over is the zeros command. So np.zeros, and the np.zeros does nothing. If I were to pass a single number, it would give me a 1D vector. If I were to pass 2 numbers, it will give me a 2D. Okay, this is not how I'm supposed to pass in the 2D. If I were to pass a single number, I will get a 1D vector. If I want to create a matrix, I would have to pass in a tuple, which will denote that size. So for example, I pass in a tuple of 3 cross 3. So this is 3 rows and 3 columns. I will get a 3 cross 3 matrix, and you can do 3 rows, 4 columns, and you guys would get a matrix full of zeros, but it would have 3 rows and 4 columns. So this is what the np.zeros command does for us. A similar command is the np.ones. The np.ones, if you guys pass in a single integer, it will only give you a 1D array. But if you guys will decide to pass in a tuple which would have, let's say, 2 arguments, let's say 3 and 4, it would pass in 3 rows and 4 columns. But obviously all of these rows, all of these rows and columns would just have ones because we passed in the ones command. So this is what the np.zeros and np.ones command does for us. The other command that I would like to go over is the np.linspace command. So np.linspace, and what this does is for us is that, let's say I pass in the first argument, which is the starting number, and the second argument, which is the ending number. What this command does for us, it gives us all numbers between 0 and 5. Obviously we get a bunch of floats between 0 and 5. But let's say I were to pass in an argument, a third argument. So what this third argument would do is that this third argument would tell Python that, okay, between 0 and 5, both of these numbers being inclusive, I want you to return 10 numbers. Okay, I want you to return 10 numbers between 0 and 5 which are equally spaced. All of these numbers should be equally spaced. Okay, they should be 10, but they should be equally spaced. So if you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we get 10 numbers. A better way to explain this is using another example. Now I'm telling NumPy that, you know what, give me 10 numbers between 0 to 100 and they should be equally spaced. Like, by equally spaced I mean the difference between them should be equal. And if I run this command, I get 10 numbers which are equally spaced. 0 plus 10, 0, 11.11, then 11.11, is 22.22. Obviously, if you were to add 11.11 to it, 33.33, 44.44, you guys get the point. So we have an equal difference of 11.11 between all of these numbers, and this is what the linspace command does for us. Starting number, ending number, and a third argument which returns the amount of that number, but all of those numbers are equally spaced. So hopefully that point is clear. Moving forward, the other command I would like to go over is the identity matrix. So for people who are watching this video who have taken up a linear algebra course during their undergraduate years, or who are aware with what linear algebra is, I'm pretty sure they are aware of what an identity matrix is and what it does. So an identity matrix is nothing but a square matrix, and square matrix is nothing but equal rows, equal columns. But all of the numbers inside an identity matrix are 0 except for the diagonal. What do I mean by that? Let's check it out. So let's say, and the command for creating an identity matrix is np.I. The np.I just takes in one argument, and that argument is a number which will be the same for the number of rows and the same for the number of columns, as it's a square matrix. And now I get an identity matrix, 4 cross 4 identity matrix, with all the numbers being 0 except for the diagonal. So as you can see, the diagonal has 1. So this is what the np.I command does for it. It returns an identity matrix with taking into consideration the number that we have passed in. So if I were to pass in, let's say 9, I would get a 9 cross 9 identity matrix. So yeah, that is the identity matrix for you guys. Moving forward, I will be going over a few other important commands, such as the random command. So what the random command does is for us is that, let's say I pass an argument np.random.ran_n, and I pass in 2 arguments. So what this does for us is that this random n command returns the matrix of our choice. Obviously we pass in the number of rows, the number of columns, and all of these numbers are from a normally distributed, how do I say it for guys who are not aware of statistics, it returns values between a normally distributed curve or a Gaussian distributed curve. Okay, so yeah, basically you guys can just say that we are getting random numbers, and these random numbers are between a specific range. So that is what the rand command does for us. And if I were to just say rand, I would probably get, so the rand n returns numbers between a negative and a positive range, whereas the rand command, just simple rand command, it returns numbers between a Gaussian distribution. The numbers are between 0 and 1 at all times. So all of the numbers between 0 and 1, I get those random numbers back, obviously in the shape of a 5 cross 5 matrix. If I would say 5 cross 4, I would get numbers between 0 and 1. So this is what the rand command does for us. But the rand and the rand n command are mostly used for later on in when you guys start to deal with statistics in detail. But the other command that I would like to go over, which is actually used considerably and extensively, is the rand int command. So np.random.randint. So what the randint does for us is that it takes, just like the linspace command, it takes in 3 arguments as well. So let's say 0, it will take in just let me close this. It will take in 0, it will take in the ending number, and it will take in a 3rd argument. So unlike the linspace command returns us 10 numbers, but these 10 numbers are equally spaced. The randint command will return 10 numbers, but these 10 numbers are random, completely random, and they are between 0 and 100. So I will get 10 numbers between 0 to 100, and they are completely randomly spaced. So this is what the randint command does for us. If I were to say 5, I would get 5 numbers between 0 and 100. 100 not being including, 100 is exclusive, 0 is inclusive, and yeah, that is what the randint command does for us. Random numbers between 0, starting number, ending number, and the amount, 3rd argument is the amount of numbers that we would like to have. So yeah, this is what the randint command does for us. Moving forward, so let's say I have a variable by the name of ARR, and let's say I pass in an argument of 5. So what I have over here is that I told Python that give me a 1D vector which has 5 elements. But now let's say if I want to reshape it. So how can I reshape it? Reshape as in create a 2D matrix out of a 1D vector. So let's see how we can do it. We can tell Python that np.reshape, it's arr.reshape, and we can say 5, 1. If I do that, I just reshape my entire, first it was 1 row 5 columns, now it is 5 rows and 1 single column. A better way of doing this is, let's say I create the same variable ARR, but over here I pass in 25. So now I have 25 elements in this array from starting from 0 up to 24. So if I were to reshape this, I'll probably tell Python that reshape this ARR variable into a 5 cross 5 matrix, and Python does it for me. Now I have a 5 cross 5 matrix, 5 columns, 5 rows. So the reshape command does nothing but takes in the 1D vector and reshapes it into a 2D matrix. So yeah, a few final commands before I wrap this video up. We have our array, which is a 1D vector. If I want to find the maximum, I can just say arr.max. So 24 is the maximum number. arr.min will return us the minimum number in that 1D vector, or it can be a 2D matrix. And if I were to check the space, the shape of my 1D vector, I can just, I can just pass in arr.shape. The shape command would tell me basically whether it's a 25 cross 1, 1 cross 5 cross 5 matrix, whatever the case might be. It just gives us that shape. So let's say I have arr as dot reshape 5,5. Now arr, this variable of mine, is a 5 cross 5 matrix. If I were to check the shape for it, I would just say arr.shape and I get 5 cross 5. So yeah, the shape command just tells us what are the number of rows and columns inside of my matrix. If I would check the type for it, just type d type, and it's an integer 32. Obviously the elements inside of it are integers. So yes, in this video we went over a number of commands when it comes to NumPy. The best way to get started with NumPy is to or any other library of Python for that matter is to just practice. I have went over these commands only once, but it is recommended that you guys go over all of these commands 5 or maybe 10 times. Just type it out yourselves. Type that code down yourselves, and because until unless you do that yourselves, you guys will never build that muscle memory, and you will always have to refer to Stack Overflow, and that concept will not be clear inside of your heads. So yeah, do it yourself, code it out, extensively, do it yourselves, because that is the only way in which you will truly increase your programming speed. And obviously I'll be creating an exercise video as well just for NumPy. You guys will get plenty of practice. I hope you guys like this video. If you do, just give me a like, share this video, subscribe to my channel. I really appreciate it. And in the next video we'll be going over some other commands of NumPy. Thank you.